Hey, Owen. Here is the homework assignment for R4. We'll see how far we get today, but there's that. If you want to, pause the video to write that down, there is that. But we are talking about rational expressions and radicals. We've been doing radicals. What's a radical? Square root, cubic root, fourth root. Those are all radicals. But what is a rational expression?
1 plus 2.
Like we did polynomials last week, right? We did polynomials. And polynomials were like x and x squared and x cubed and like combinations of a whole bunch of things, right? Have we done absolute values yet?
Yes.
We did do some absolute values. Okay, so we did absolute values. Okay, absolute value of x. And it's more intricate than that. There's numbers and stuff in there. But those polynomials, absolute values, we did some radicals, but now we have rational expressions. What are rationals? Yeah. Rational expressions has an x on the bottom, right? So like 1 over x or 1 over x squared or any combination. It can be longer than that, obviously, but 1 over x and 1 over x squared. All right, now you calculus kids should know what 1 over x looks like when you graph him. He has a vertical asymptote, but he also has a horizontal asymptote. And he looks like this, and he looks like this. He's like a boomerang thing. Somebody named that the boomerang function, right? Okay, so he does not cross over the middle line, and he does not cross over the horizontal line. Okay, that's 1 over x. 1 over x squared. Do you remember what 1 over x squared looks like, calculus kids?
Volcano.
He looks like a volcano, so he's the same. Yes, he is. Okay. He is the same, but the other part is flipped up. Bye, Brady.
He's going to get his nasty.
That's 1 over x squared. So if x is on the bottom. Now, here is something that people get confused at all the time. Let's say I have 3x plus 5 over 4. Is that a rational function?
No, because the x is on the bottom.
Correct. Because this is a number here, this is 3/4 x plus 5/4, right? That's a linear function. That's a polynomial, right? So x has to be on the bottom in order for this to be a rational function. Got it? That was a whole lot of information all at one shot. Are we good to go? Yeah. To the right a little bit. Oh yeah.
Because it can't cut
It goes all the way across.
No, I mean on the thing that says cricket.
What?
The thing that's cutting the
Because
vinyl.
that's where the blade is. The other side is for a marker.
What are you talking about?
See, that's what we had to say.
Well, you're not making sense with your question.
All right, are we good? Okay, let's go down. Example 1. Determine the restrictions on the variable for each rational expression. In other words, they're saying, what can x not be?
Is that like discontinuity?
Okay, what can x not be? Where are we going to have problems? Okay?
Is that like a discontinuity?
Yep. Now the problems are we cannot have 0 be our denominator. Okay? I have posters around that say like friends don't let friends divide by 0, and it's all fun and games until someone divides by 0. So, no 0 in the denominator. Cannot happen. Cannot happen, right? Because let's say I have like 3 divided by 0. That's undefined, right? What is 0 divided by 3? 0. That's legal, right? This is legal. Okay, but I cannot have, this is illegal. Illegal. I cannot have 0 on the bottom. I can have 0 on the top, but I can't have 0 on the bottom. So when we're looking at each one of these, we're looking to say, like, what can x not be, right? So some of you can do this in your head, like, very easily, but, like, I want the x plus 2 to not be equal to 0, basically, right? And then it's kind of like an algebra problem from there, right? If you subtract the 2 over to the other side, x cannot be negative 2, right? And some of you can do that in your head. Like if x was negative 2, you would end up with 0 on the bottom, right? Okay. Now, what about 3? Can x be 3? Yeah. Yes, because I can have 0 on the top, but I cannot have 0 on the bottom. So x cannot be 0. Determine the restrictions on the variable. That's my restriction. X can't be 0, yeah?
It can't be negative.
Or negative 2, that's what I mean. X can't be negative 2, because then the bottom would be 0, right? This is a vertical asymptote.
Yeah.
Hole is when it cancels the top.
Yeah.
Okay.
It's like a difference of square.
All right, this guy right here, we're looking just solely at the bottom, right? But x squared minus 49 is a
Difference of squares.
Difference of squares, right? Okay, he breaks down into
X plus 7,
Squared
x plus 7, x
plus
minus 7. Yeah, yeah? Okay? Now, we don't care about the x on the top. We care about the x on the bottom. So, can't be positive 7, can't be negative 7, right? X plus 7 can't be 0, and x minus 7 cannot be 0, right? So, if I subtract the 7 over, x can't be negative 7, x can't be positive 7, right? Or if you want to write them together like Zach said, x can't be plus or minus 7.
What? It could be negative 7.
It can't be negative 7. Okay,
Oh, 'cause
if
it was
x was
positive.
negative 7, and I put negative 7 in here, negative 7 plus 7, this guy would end up being 0. Now, this guy would end up being negative 14, but what's 0 times negative 14? Still 0 on the bottom, so that's bad. Okay? All right, so we got to look at both sides of it to make sure that whatever we plug in is not going to end up giving us 0 on the bottom.
Can you like not break it down and can you just look at the thingy?
Sure, I mean, yeah, kind of. So another way of thinking about it, if you don't know that that's a difference of squares, you could say x squared minus 49 can't be 0, right? Okay? And x squared, if I add the 49 over, x squared can't be 49, and if you take the square root. But the problem with that is, the square root of 49, some people put just 7. But when we put, you guys don't know this yet, you two girls, when we insert a square root into a number, you have to take plus and minus, right? So 7 is the square root of 49, but also negative 7 is the square root of 49 when we insert the square root in there, okay? That makes sense? So you can look at it as a difference of squares, or you can just set that thing equal to 0, but just don't forget the plus and minus. Got it? Okay, C. Ooh, oy vey. We've got an x and a y.
Can't figure it
So
out.
we're saying what can x not be equal to, and what can y not be equal to?
Oh, 0.
X can't be 0, because if I plug 0 in, 0 squared times anything, all that stuff is going to end up knocking out to be 0, right? What can y not be? 0. Anything else that they can't be? No, just 0, right? X can't be 0, y can't be 0, because that would knock it, because I'm only multiplying here, so the it's just going to knock the whole thing out to be 0 on the bottom. Got it? Okay, so that's what it means when it says determine the restrictions. What can x not be equal to in order for that to work? Okay? All right, simplifying rational expressions. Now we're breaking stuff down. So these are going to be like you calculus kids, where the holes are at, right? Okay, so I have x squared minus 16 on the top, which is a difference of squares, right? Okay, so I'm going to put him over here. X plus 4, x minus 4, he's going to be over here. Boop. Okay, what about the bottom?
You can't do it.
He's a simple trinomial. What can we multiply to get 12, but when I add them, give me negative 1?
Negative 4 positive 3.
Okay. I'm going to do x minus 4 and x plus 3 here. It doesn't matter what order you go in, but then I have them top and bottom. All right, so calculus. My calculus kids. These guys on the bottom, we would say that x can't be what? X can't be positive 4, right? And x can't be negative 3. Now, what's happening in negative 3?
There's a
There's a va. What's happening at 4?
There's a hole.
There's a hole, right? Do we understand that, calculus kids? Okay, you don't have to know that if you're not calculus, right? But the 4s cancel out, so there's a hole there. The 3 doesn't cancel out, so there's a va there. Okay, you guys will all know that, like maybe by the end of this chapter.
But
We'll
like,
talk about that.
because the 4 cancel out, do you have to put the 4?
I think all we're doing here is simplifying, so they're not asking for what it can be and what it can't
So
be.
you technically have to.
So the final answer to this is not even this stuff. They didn't even want us to do that stuff, right? They want us to simplify. So what's my answer? X plus 4 over x plus 3. Now, here's the deal. You two girls, I see people all the time coming into Algebra 2, and they say, whoop, let's cancel those and have it 4/3. Can you do that? No, because they are,
Locked in with the
they're trapped. They're locked in, right? The x plus 4, if he's going to cancel, he has to be an entire piece, right? Plus, like, joins them together, okay? So they cannot go freely. Now, if this said 4x and 3x, then I could cancel the x's, right? Because multiplication doesn't lock him in, right? Only addition, subtraction makes him locked in. Okay, good thought. There is that. All right, B.
Can we take a 4 out?
I don't even have any variables, but they want us to simplify, right?
Can you divide by
Take a 2.
Okay.
So can we just plug it into our calculator?
Nah, they don't want us to. They don't want us to evaluate 7. They want us to simplify.
So pull it.
This means 8 over 4 plus 2 square roots of 7 over 4.
So
Yeah?
can we just
Just pull the 4 out. Multiply everything by 4.
No. No. What's 8 over 4?
oh
2 plus the square root of 7 over 2, because this becomes a 1 and that becomes a 2. That's what they want. Right?
Well, that's
You're reducing, you're simplifying, right?
Every knob did.
That's kind of silly.
not what I'm
That's kind of silly. Okay? Make sense? Ish, kind of? That was weird. There's not even any variables there, right?
Well, I think we're
Okay.
knobs.
All right.
What time do you get out of here? It's behind your two.
Oh, I don't know.
10:37.
10:37?
It's 10:05.
Okay. We'll go a little bit longer. All right. Okay, I'm gonna caution you this, okay? Look at this little example right here where it says factor out, blah, blah, blah. Let's look at this right here, okay? 4 minus x and x minus 4 are not the same thing. But if you want to be able to cancel them, I'm going to pick on the 4 minus x, right? If I pull a negative 1 out of 4 minus x, that becomes negative 4 plus x, true?
Yes.
Or another way of writing this is x minus 4. Then this guy will cancel with that one and negative 1 is the answer. So just keep in mind, if the signs are flipped, you can take a negative 1 out and cancel. Got it? Yeah, yeah? Just as a caution. All right. Okay. All right, multiplying and dividing rational expressions. Let's go down here. Whoop. Okay, example 3. All right. This is division. When you're dividing, you keep this guy, you flip this guy, you flip this guy, right? Keep, flip, flip. So I'm going to keep the x cubed minus 8 over 4 minus x squared. He's just chilling, right?
Why don't you keep get it?
Times, I'm going to flip that to multiply, right? And this is going to be x squared minus x minus 6 over 3x squared plus 6x plus 12, right? That's what we've got. Okay? We got a lot of work to do.
But you don't flip the sign.
We got a lot of work to do. Okay?
Why don't you flip the signs?
What do you mean?
like
When you move from top to bottom.
No. No.
How come we did that with like exponents and stuff?
Okay? Let's say I have 2/3 divided by 1/4. When you keep flip that to the top, that becomes 4 over 1. It doesn't have anything to do with a negative. That's only when you're dealing with exponents is when you make them positive, negative. Okay? Yeah, yeah? So this is all we're doing here is we're just flipping them, right? We're multiplying by the reciprocal, right? Okay? So here's this. All right. So let's dissect some stuff. What is x cubed minus 8?
Difference of cube.
Difference of cubes. All right, I'm going to write the formula in here. It is a minus b. Do you have this memorized?
a minus b squared plus ab plus b squared.
Look at you go. You don't have to have it memorized, but there's that, right? Okay. All right, what is A?
X.
X, and what is B? 2, right? Okay, so this top part, I'm just going to write them down here, is x minus 2. A squared would be x squared plus
2x.
2x plus
4.
4.
And then the bottom is
Okay?
Bottom's a difference
You mean-
where-
All right, now hold on real quick.
No, it's adding.
No,
What?
it's not different squares.
Yeah, it is.
The bottom's
Technically, it is right now.
square.
It's a difference of squares. Okay, but I'm going to do one thing first. I'm going to do one thing first before we factor the difference of squares.
oh my gosh.
Because if we factor this guy, this will be 2 minus x and 2 plus x, but I don't want to do that, right? So I'm going to do this first. I'm going to take a negative 1 out of that thing, and then this guy will end up being what?
Negative 4 plus
X.
X squared minus 4, if I read it like that, okay? Because that's the form that I want to see it in. Okay, so I'm going to take a negative 1 out, and then x squared minus 4 is x plus 2x minus 2, because he's going to end up canceling with some x plus 2s and x minus 2s over here. So I'm going to take that negative 1 out first before I do the difference of squares, right?
Cancel those minuses right away.
You could cancel this guy and that guy right away. Yeah.
Can we break down the top trinomial?
Part.
Or aren't we doing
Oh, this guy right here?
Yeah.
No, because there's nothing you can do to give you 4, but when you add them, give you 2.
Oh yeah.
1 and 4, 2 and 2. Not going to work. What? 2 times 2 gives you 4, but 2 plus 2 is not going to give you 2, right?
I'm running out
Right.
of time.
Okay, good? All right, so do you see what I did with the negative? I pull the negative out first, and then I do the difference of squares, yeah? Okay, so there's that. All right, this top guy right here, x squared minus x minus 6, he is a simple trinomial. Multiply to get negative 6, add to get negative 1.
6 and
X plus 2,
X-
X minus 2.
x plus 3 minus 3 plus
Minus 3 plus 2, right? Okay?
Wait, can you just?
You may just chill for a second? I'm not going to cancel yet at all. Okay, what about this bottom one?
Hey, isn't that a simple trinomial on...
Complex trinomial.
No, he's not.
We just went over this.
No, he's not. What is he? He looks like a complex trinomial, but what is he?
No.
Missing out.
Oh, you
Can't you take a?
what?
Let's GCF him first, right? And then he's x squared plus 2x plus 4, right?
Didn't we?
No.
We just did.
Does this guy break down? Is he a simple trinomial?
No.
No, but look what he is.
He cancels with
He
that.
cancels with the whole big other thing, right?
Yeah.
Okay, so we've broken everything down. Now I cancel. Now we go to the fun part, right? X minus 2 cancels. X plus 2 cancels. This guy cancels here, and this guy cancels here. So, let's see what is left. What's left on the top?
Where's the minus?
X minus 3.
Okay, what's left on the bottom?
Negative 3.
Negative 3. Can I cancel this negative 3 and that negative 3?
No.
No, because the top one's trapped.
They're locked in.
Right? They're locked in. X minus 3 has to go as a whole unit because they're trapped together by that minus sign. So this guy is done. Now, what you could do, and Jacob Carr might say this, what's another way of writing x minus 3 over negative 3?
Negative 3 plus x.
Square.
Oh, okay. We're
Right? That's what that means, right?
That's
Yay?
Were you getting there, Jacob?
What? No.
Jacob likes to do crazy weird stuff like that.
Wild that we
It's
went from
backwards.
that
It's
to
like
that.
you had the 1/3 and then I changed it to over -3.
Oh, you like it written like this?
Yeah.
Okay, sure.
Because you had like the.
Okay. But here's my deal though. Like this is my kind of pet peeve and stuff that they do to you like on the ACT. Ready? You get to this answer, and this is how it's listed.
Yep.
That's horrible.
not
They do-
So you have to know, like not this intricate. Like they're not gonna have you do problems like that. That's way too advanced for probably the ACT is gonna have you do, right? But I'm just saying, a lot of times what they do is you'll get to this answer,
If I had an
but it'll be
equation
listed like this.
I would
Okay.
guess.
What'd you
Oh,
get?
without a doubt.
Do you think so?
If
Yeah.
What are we allowed to cancel out and what are we not allowed to?
I
Only
got a
groups
minute.
that are exactly identical.
I'm skipping a lot.
But
So
what
like.
if-
But it can be across.
But, oh, good question. Yes, Trevin just asked, what are we allowed to cancel, what are we not?
Just say name.
If one is in the numerator, one is in the denominator, right?
Oh.
So it can be here and here, numerator, denominator. It can be here and here, numerator, denominator. It can be here and here, just as long as it's not here and here.
One of these
Or
days
here
you're
and
gonna
here.
give
One
your
has to be
key
in the
to
top, one has to be in the bottom.
She's gonna
Wherever
knock
it's
it over,
at,
gonna
doesn't matter,
crush
right?
it. She's gonna
As long as one's in the top, one's in the bottom. I'm gonna crack my screen, is that what you said?
Yeah,
You're
one
gonna
of these days.
break your television.
Boom. I'm gonna crack it with my pen.
Uh-huh.
No, you're not. You're too weak.
Okay? Good question.
I don't
What
know,
else?
R4, you're,
Can
like,
we
like a
work on
4-year-old
homework
report
now?
card, so-
Yeah, let's
Oh, yeah, I
stop
remember.
before we get to adding and
You're all
subtracting.
Thanksgiving
So
memories.
you should get all the way up to adding and subtracting rational expressions, and that is like I don't know where. I need a book.
My book's right here.
Add and subtract rational expressions. This is what section R4.
That'll
right?
make your hands smell like burnt metal.
I think it smells like eggs.
Eggs?
It's
Can you
weird.
Show me what it'll say.
I'm sorry, what the freak?
You can't see the detail of the person. I don't know.
And the
Is it
text
for
isn't
Kenna?
over here.
Yeah.
But
Yeah, you should maybe.
Yeah,
Give
73.
me the text.
What?
Rena.
Yeah, I'm gonna make her do a thicker text to make it. Holy cow! Up through 34 is all.
10, 12.
I guess that's like half the problems right there. So up through 34. So 7 problems you can do. Okay.
Tell me what's the next length.
The last length.
That's what I meant.
yeah, those right now. Do it during your key.
Oh, methyl.
Oh, that's what I'm gonna roll them.
The last one is
We got
like 22.
And it's just one.
22?
It's just one on the left.
So
Wait, like we go
it'll
this
be
one
on
up.
this side.
Yes. Yep. Now, if you by chance accidentally put it like on the left, we can always move it over, or like this, Matt, this needs to be loaded.
Yeah, you're not gonna do this.
What, did I say 22? 22.
No, 34.
No.
Shut up, Casey, you're gonna confuse me.
go with 22. 34, Dylan.
Ooh.
Let's get like
Okay.
4 high.
Were we supposed to do all that count?
No.
Oh. Miss Commissioner,
What?
we need some help.
Already? We just started.
Well, do they let us use imaginary numbers in this? Or not?
Why are we using imaginary numbers?
Oh,
here,
I like
Jacob?
it. Yes.
So we use
So,
imaginary
determine the
numbers?
restrictions.
4i?
So, it cannot be an imaginary number, which means it can be anything once. I would say T.
Just all real.
T equals all reals. Yeah, it can be whatever it wants to because it's plus, right? It's not a difference of squares. What? Do we need to talk about 12?
Yeah.
10 or 12? 12? Let's talk about 12 real quick.
Yeah.
Oh, I'm still recording. I'm gonna put it over here. Number 12, read me the top part. It's T plus 16, right? T squared plus 16.
Plus 16 over T on the top.
On T on the top. Okay, what can X not be? So here's the deal. I don't want this bottom to be equal to 0, right? Okay, and if I do that, I subtract 16, right? And T squared cannot be negative 16, right? And if you take the square root, 16, this ends up being technically, the square root of 16 is 4, but the square root of a negative is I. So and it's not T squared, it's just T, right? Okay, so this is saying T cannot be an imaginary number, which means T can be any number, right? Because I'm adding on the bottom. I'm squaring a number and I'm adding a number. Is this ever going to be negative or is this ever going to be 0? No, because in order for it to be 0, T squared would have to be negative 16. So it's never going to be 0. So T can be all reals, or you can just put all reals, right? T can be whatever it wants to be. Okay, all right, I'm going to stop recording for Owen. Bye, Owen.